All right, in this first example video, we're going to explore the SAS congruence. That's side angle side congruence. The book actually has a pretty good visual for this, so I'm going to insert a little video and then we'll move on to the example in your notes.
Given two triangles with two pairs of sides congruent and the included angles congruent, verify that the triangles are congruent. Note that side RS is congruent to side XY, side ST is congruent to side YZ, and that angle RST is congruent to angle XYZ. To prove that the triangles are congruent, show that a rigid motion maps triangle RST to triangle XYZ. Translate triangle RST so point S maps to point Y. To differentiate between triangles, we label the translation of triangle RST as triangle R', S', T'. Since the translation maps point S to point Y equals point S'. Now, rotate triangle R', S', T' about the point Y. So segment S', R' coincides with segment YX. Since rotation preserves length, the length of segment R', S' equals the length of segment RS equals the length of segment XY. So point X equals point R'. To complete the mapping of triangle RST to triangle XYZ, reflect triangle R', S', T' across line XY. Since reflection preserves angle measure and length, the measure of angle R', S', T' equals the measure of angle RST equals the measure of angle XYZ. So segment S', T' coincides with segment YZ. Additionally, the length of segment S', T' equals the length of segment ST equals the length of segment YZ. So Z coincides with T'. Because the vertices of triangle R', S', T' coincide with the vertices of triangle XYZ, there exists a rigid motion that maps triangle RST to triangle XYZ. By the definition of congruence, triangle RST is congruent to triangle XYZ.
All right, so now let's look at the example in your notes, and I like the transformations that video just went through and how it showed the transformations. So one thing I want to point out, we're trying to find what rigid motion or composition of rigid motion shows that triangle UVW maps to triangle XYZ. First, I want to point out that we have some congruencies in our triangles. XZ is congruent to UW, YZ is congruent to VW, and angle Z is congruent to angle W. So what you notice is you have two sides and the included angle. Included angle is if you were to connect your two congruent sides, it's the angle formed by those two sides. It's included between the two sides. So if you have two sides and an included angle congruent to two sides and an included angle from another triangle, through rigid motions, these two triangles will be congruent. The one thing that I do want to point out with the order of writing out our triangles, so triangle, first it was a U, then a V, then a W, that's very important. Over here, triangle X and Y and Z, whatever the first vertex is here, U, should be congruent or will be congruent to this vertex X. So U and X will end up being congruent when we show the rigid motions that go. V and Y, so here's V and here's Y, will be congruent. And Z and W, which we already told were congruent, are right there. So what composition of rigid motions? What I liked about that video is they started by doing a translation. Let's get angle W and angle Z mapped to each other. So we're going to translate triangle UVW I guess I'll just say to the right. And we want W prime to be equal to Z. We want that to map onto itself. So once that happens, so just kind of imagine that this is moved over, translated to the right. Now we can rotate this around until W prime U prime maps to XZ. So we'll do a rotation, and that's a 180-degree rotation. So next we'll rotate 180 degrees, and we want, let's say at this point, once that's mapped over, that's a U double prime, we want it to map to X. So U double prime will be where X is. Then, so let me just kind of sketch, here's what I'll do it with dotted lines. So here we would have, let's see, we translated to the right, then we rotated. So this is V double prime down here. This is U double prime, and then W double prime is right there. Then the last thing we have to do is that reflection across this side right here. So V double prime is going to map up to Y. So we'll do a reflection that will get V. I guess once it maps up there, it's going to be triple prime to map onto Y. So this V double prime is going to map up here. This is going to map to that. That's going to map to that. And we are showing that the triangles are congruent with rigid motions.